collect the signatures of different classes. Maybe Sai Priya, we have given 4 classes, is it?
Yes, yes. So
Yes, four.
you will be dividing the image into 4 classes, which is water bodies, and the second class is vegetation, and third is built up, and fourth is others. And please follow this order 1, 2, 3, 4 in the same order.
Okay, that we will be listing when we will be giving you out. So you understood basically 4 classes you have to classify your map. So the first classification, the classification that you will be doing is using an FCC. In FCC that you have prepared using the data set, whatever data set that we will be giving it to you. Okay, so based on your boundary file, you will be making FCC, and then from that FCC, you will be classifying, taking signatures from each of the classes. Okay, and then you will use it. So while classifying, you make sure that you take signatures considering the Google Earth map also as a reference so that you can understand, okay, if you are taking signatures, it is being taken in the area which you are trying to classify. Maybe you can take some signatures from urban, then you can take it from uh, water body, etc. Okay, everywhere you have to take considerable amount of signature and then classify it. The next thing you will be doing is you will take signatures as per your boundary area from Google Earth. Okay, those signatures when you bring it and you convert it into shapefile and you use it for classification, then finally you will be doing an accuracy assessment. Okay, of both the map, the classification map that you will make from FCC and the validation map that you will be making from Google Earth. So your classification result or your project assessment will be based on your accuracy value. Whatever your accuracy assessment comes, whatever your kappa value comes.
And please try to get your kappa value at least above 0.75 or 0.8. So that is the optimal value to use it for further studies. Okay, so I'll tell you.
I'll just give them some basics of accuracy assessment. Just
Yes, yes, I show you.
is my screen visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So basically, when I meant about accuracy assessment, what we are intending that how much accurate your classified map is. So accuracy assessment information, it is difficult to address, but the classification is always incomplete about without an accuracy assessment process. So it is defined as a percent of correspondence between what is observation and what is the reality. Okay. So accuracy is usually judged against any existing map. So here your existing map is going to be your Google Earth validation map that you will be preparing. Okay. Any large scale aerial photos or field check. So each category of classification really present as a point specified on the map and are the boundary separating categories valid as located. So these are the two basic questions that you will be looking at, whether each of the category that you have assigned in your classified map is same in the validation map, and also all those boundaries of those categories to match. So how do you try to achieve a level of accuracy? It is on the basis of the suitability of training sites, whatever sites you have selected. Then the size, shape, distribution, and frequency of occurrence of individual areas assigned to each class. So you have to see that. Then there is also something which is there, sensor performance and resolution. So since you all will be using the same data set, then it won't be a problem because your resolution is going to be this similar for all, and the method involved in the classifying. So both the methods you will be usually using the same classifier, that is um so here you can see in coarse resolution it is ineffective. From this map you can see, sorry,
नहीं नहीं डस्टबिन
sorry, Can I continue?
Yes,
Yes,
Ashwini.
ma'am.
Okay, okay. I think there was a disturbance in the middle. So you can see when we look at uh, this map, this image, so we can see how they have tried to categorize it. Like this part, it is 100% pasture. Okay, but you can see in the boundary, this boundary, it is 60% pasture and 40% secondary forest. Okay, here it is pasture. Some part of secondary forest has come here. Again, here you can see it is 100% primary forest and this is 100% secondary forest. So what will happen when you see your FCC? When you will see your FCC, also there will be instances when you will see there is some kind of mixed pixel, not entirely from one class. So you have to let the classifier decide how those pictures are classified. Okay, so these areas are going to be tricky when you will be doing classification. So more the coarse resolution. So if the resolution is coarse, then there are a higher chances of these pixels to have mixed values because there is more information in one pixel, stored in one pixel. But when it is high resolution, high spatial resolution data, then it is more easy to distinguish between the categories that are in 2 pixels. So basically, the task is to compare a map that you have prepared from remote sensing data with another reference map and from different source material. So your one map is going to be from your Landsat data and the other map that you will be preparing is from your Google Earth. So the reference map is assumed to be accurate. And if there is any kind of season, suppose you are in this case you are just normally working, but if there is some data, some kind of data that you are evaluating for seasonal sensitivity, then you should think that both the maps are taken from the same season. Like if it is during spring season when mostly new leaves come or there is shedding of leaves, and those things affect your classification and validation results. So both maps should be mapped at the same level of detail. The detailing kind of a thing should be same for both the maps. So basically you obtain your accuracy, you will get this um, uh, confusion matrix or contingency table. Here what happens in classification, whatever you values that you have classified, that comes in rows, and whatever ground truth the classifier has classified, that comes in column. The diagonal elements, it represents what is at what level both classification and validation or the classification of ground truth, the results agree to each other. So that is with the reference data it tries to interpret. So of diagonal elements that is represented in each row and column has been misclassified by the classifier. So these are called commission error. Uh, okay. So like that, from confusion matrix, it can be seen that at least two methods can be used to determine the individual accuracies. One is the producer's accuracy that happens. It is basically to check inside what is the accuracy. Maybe you can go there and find out the accuracy of that location. So you basically you go there and take a GPS point or a GPS location you mark there, and then you indicate that the probability of a pixel that is classified into a given category actually represents that type on ground also. So that is called the user's accuracy. And in producer's accuracy, you see that whether it is correctly classified, basically checking through an image or indicating how well the training set pixels of a given cover are classified. So basically, you measure an overall accuracy, that is total number of diagonal elements upon total number of reference pixels. So you can see what is your accuracy. It is 97% for in this case it is water. Then you can see for sand it is almost 66%. So it has a large number of pixel that has been misclassified. You can see on the base they have used in the total number of reference pixel, that is 328, and the pixels that were correctly classified. So every you can see the best water body is giving the best accuracy, that is almost 97%. However, you can see here U is urban area. Urban area has a least accuracy of 42%. So at last you will use a kappa matrix. In kappa matrix, as Cypre already told, like your a good result should vary between 0.61 to 0.8. We will consider it a good result. Try to achieve something between substantial agreement and near perfect agreement. I hope it is clear.
Yes, ma'am.
So now everyone has the idea about how to do the land use classification, how to do the accuracy check, right?
Cyber, I also want to show them one thing. Can you just share your screen with some FCC, Zoom and FCC?
Yes, yes.
Actually, this is a hit and trial process to get a good accuracy. I just want to share one hands-on trick which may help you in doing it properly.
Hmm. Yes, Aishwarya, continue.
Okay, okay. I have requested control. Have you given me control?
No, I didn't. Oh, okay. Yes.
Yeah, okay. So Landsat is a 30-meter resolution data. So when you are trying to classify any class, any particular class for say urban area. So here I am looking at urban area. So these classes are, this is basically urban area in the region. Okay. I'm just assuming for now, like these pixels that are appearing to be blue in color, maybe they are urban areas. Okay. And maybe even this part which has a little mix of this tint may also be classifying as urban area, like somewhere a plant is there in the middle, but mostly it is mixed urban and vegetation, some kind, one tree or two tree has come in the middle. So for the first time when you classify, I would just request you that you try to take pure pixels. For example, somewhere here. Okay, so it helps the classifier to identify and distinguish between the areas. So when you take the classification, you are trying collecting signatures for the very first time. For very first time when you are running your classification, then for all classes, try taking the pure pixels first. Okay, so here, for example, for urban area, you may take this pixel. For water body, maybe you can take these bright red pixels here. Okay, so the first time when you classify, then you will be able to understand where the classifier is classifying when you have taken just the pure pixels into consideration. Okay, later when you, after the first classification is done and you check it from your Google Earth map, okay, the classifier has not classified it properly, or maybe at various places it has misclassified because it is not able to distinguish between what pixel is this or wherever the mixed pixel is there. Then on those particular areas you start taking signatures and trying to classify. Okay, but very for the very first instance, always begin with taking the signatures at pure pixels, so that will give a little ease in doing a classification. So this is just a hands-on tip, that what I can say. And otherwise it is an iterative method, so you need to do it a couple of times before it is satisfactorily classified. But anyway, it is going to help when you proceed with it. Okay, that's all from my side. I hope this was clear to people.
Yes, ma'am.
Yes, ma'am.
Okay. Okay, Cypriya, that's all.
Okay. So have you all understood how to take the signature, and just don't stop by one attempt itself, because you need to verify and you have to do number of attempts to get a proper classification with good kappa value. Okay. And for some cities, like for hilly areas, it will be little difficult. So better first you study about the complete data set, like what types of features are there and how they are being represented in the FCC. So first study the entire image and then take signatures in a very strategic way, like how to optimize your number of attempts. So just while doing, just think before you take the signatures, and take as many signatures as you can. Don't just take 10 signatures and finish off your classification. Okay. So for the mini project, we have assigned one city for each of the each, and everyone will be doing a land use classification for 2 time periods, which is the 2009 2019 data sets. So before, along with that, you have to do a kind of preliminary study about the city. So you have to develop a layer of population change as well. So you have to take the census data for this, and then also you need to develop a DEM profile, and you need to find out the 3 land cover indices, and then the land use map, which has 4 classes: water, vegetation, built up, and others. And in case of land use, like if you have the city is having agricultural land, which some part is cultivated and some part might be uncultivated. So in that case, the cultivated land you take it as vegetation, and cultivated you can take it as others itself. And then you need to download a survey of India map, and digitize the water bodies from the downloaded map, and also extract the roads using the OSM data, and compose a proper study area map with roads, water bodies, all with all these features. And while submitting, you have to you have to upload all the output images of each step. And for land use specially, you need to upload the band set, which contains at least the main band 1 2 3 4, which is mandatory, the bands 1 2 3 4 and 5. And the signatures, the SCP files, along with SCP files, the KML files for Google Earth signatures, and also the shapefile, which is converted from the KML to shapefile with the attribute tables edited. So please upload these signatures, and along with this, an accuracy, you can upload the screenshot of that accuracy report, or also you can upload the Excel sheet, uh, which will be given after running the operation. So you can upload either screenshot of the Excel, and then the whole overall your inference about your the project as in the form of a report. So, and then you try to keep all these files in a zip folder with 3 subfolders. One is city profile, so I have given which all four files should be in city profile here. And then the land cover, so you can see all the land cover indices should be in the land cover folder, and the images related files related to land use should be in the folder land use. So I have also given the drive link where to upload the files, and then after uploading the files, you just give a mail to this mail ID about your submission with the link where you have uploaded. Okay. So I have assigned. I'll be attaching an Excel sheet to about the assignment of cities to each one, and along with that, I have given a link to download the boundary file. So is it clear about the project? Are there any queries about the project? So all the class recordings are already available in the Teams portal. So please look at those recordings and please follow those tutorial videos. Well done. And if you have any queries, you can always contact us. Any queries?
No, ma'am.
No, ma'am.
Be expecting a short report kind of a thing.
It should be very short and crisp. It
Yeah.
should be around 5 pages, not more than 5 to 6 pages.
In case of any doubt you face, any problem anywhere, please feel free to speak to us. I hope everyone has understood.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. Okay. And I think, Saitya, we can end the class here.
Yes, Bharat sir is there. I guess we can also ask Bharat sir.
Sir?
Yes, you both are teaching, so you can take a decision. If everyone is okay with whatever has been taught, you can end the class. So there should not be any iota of doubt that I did not understand this. If you have any questions, please raise it here. Okay, if you have doubts and putting it on a message or a call would not really suffice. If anything is there, they can easily show it to you here. Because from next week, I think Orco students would actually take over with the next part of the lab course. So if you have any questions, please raise it. We have sufficient time to answer your questions. Or you can even go back do some revision of whatever has been done. Then even today until 5 o'clock, this class runs. So you can even come back at 4:30 and ask them. So if there are many doubts, we can even have a half an hour or 45-minute session to explain it to you also. That's also fine with us. Right? So if there are no questions, please you can close. Thank you.
So are there any queries or shall we end up here?
Okay. Then, Saibra, we shall close it here.
Okay, fine.
Thank you, everyone.